talking about Umicore's roadmap, the NMC cathode materials roadmap, and FEOC or NDAA compliant supply chain, and why this topic is getting more and more important. So, just a quick introduction before I delve into the topic. Who we are. Umicore is a circular materials technology company. We have our expertise is basically transforming the metals from their like the raw materials, the ore form up to the material solution. So that's where our chemistry, material science, and metallurgy expertise is important, where we have the know-how how to transform this material, and then at the end of the life of a material solution, we can recycle it back to its base metal form. So we have this whole circular materials technology expertise that we call it. So that's our main business model, and we have several business units kind of looking at different applications on that one. So this slide shows the different business units that Umicore has. The battery material solution is the one which I'm representing today. We have automotive catalysis, which is one of our largest business unit. We are supplying catalysts for the IC engines. And then recycling is another big unit where we are doing complex metal waste recycling in Europe, in Belgium. We also have a pilot facility for battery recycling, where we bring it. We have a process where we do like a mixture of hydro and pyro technologies, and we are using this kind of a patented process to do that. And then we have specialty materials, where we are making materials for electronics, for like cobalt, for precious metals and other stuff. So that's more of a specialty unit that we have. So that's Umicore's introduction. In terms of the cathode materials, the battery cathode materials, the group which I'm representing here today, historically started work on cathode materials with LCO. That back then it was portable electronics. LCO was being used for that, and originally in Asia, of course, in Shonan, where we had our first plant in South Korea. And then gradually, as electric mobility became a large market, we moved towards NMC. And then we had NMC in Asia first, in South Korea and China, and then we also have a plant in Poland, which kind of serves the European market. So we gradually expanded from Asia markets to European market, and hopefully one day we will be operating a plant for battery materials in North America as well. This map shows our global locations. Cheonan, South Korea is the headquarters for battery materials. And we also have the R&D facility, the largest R&D facility there. We have a presence in Jiangmen, where we do Jiangmen and Guangzhou in China, where we supply materials for the Chinese market. We are doing precursors in China, refining and cathode production. In Europe, we are in Nysa, Poland, where we are doing cathode manufacturing. In Kokkola, Finland, we do the precursor PCAM manufacturing, and in Olen, Belgium, we have next generation R&D. And we also have a footprint here in North America for the battery materials business in Auburn Hills in Michigan, where I'm located. So we hope to expand our footprint in Europe as well, with our joint venture with PowerCo, with Volkswagen. It's called IonWave. And then we also hope to expand our production there, and we one day also hope to have a production plant in North America for the local market here. This is a picture of the production sites. This Nisa Poland production for Europe is fully renewable energy. It's driven by wind power, so sustainability is an important goal there. So the product roadmap that Umicore has, this is not just, it's also a reflection on the market and how we see it with our customers. Uh, the product roadmap that we develop is generally based on alignment with how our customers see the market, how the EV industry, how the OEMs and the cell manufacturers see the market. So we are making products for our customers. So uh, so it's kind of a reflection of the market, but also our own strengths as well. So this is important there. On the x-axis, on the y-axis, you will see the energy density, watt hour per liter at the cell level, and at the on the x-axis, you will see uh, the time to market when we plan to bring these materials into production. So currently, we have NMC uh, between 80 to 90% high nickel materials which are already in mass production, some of them, and we have some mid nickel, of course, NMC in mass production. But this kind of gives you an idea of what we see for the next 5 to 10 years, which materials uh, will be brought to production based on the customer demand. So if you look at the y-axis, you can divide it into a premium segment, a volume segment, and an entry-level segment. So this is kind of based on an automotive market, kind of loosely based on that. But if you look at a non-EV market, we can look at these premium segments for high energy and high power applications as well. So currently, we have a nickel 92, which is close to product qualification. I mean, towards the mass production MPTR is going on, and we will bring it to market in towards the end of this year. And we are able to achieve a really high capacity with graphite and silicon, depending on the application on which the cell manufacturer will be working. And then going forward in the next couple of years, we are also pushing the energy density higher by working on even higher nickel materials, nickel 94, for example. Then we are also looking at silicon anodes to pair with that to get us the most benefit in the cell. Eventually, we also plan to look at higher voltages for nickel 80 materials to see how much capacity benefit that we can get. It's also it has to be coupled with electrolyte and cell design development in order to make this possible. And then we are also looking at nickel 95 bimodal materials. There's a lot of work to be done on that, but it might be ready for scale up by end of this decade. So this is mostly for the premium segment. For the volume segment, which kind of addresses most of the market, we have the mid nickel high voltage materials. Nickel 62 at 4.4 volts can give us energy which is similar to nickel 80. So this is being brought into production soon. Uh, So, and then we are looking at the trends in China as well. You can see, and we see a trend towards the nickel 68. So Umicore also is working heavily on this grade, and we hope to bring it into production in a couple of years in order to get higher. So the whole advantage of a mid nickel high voltage NMC cathode is to get high capacity at lower cost, and this is going to be very important for the automotive industry. So beyond that, you will see nickel 70s X and then nickel 62 operating at 4.5 volts. So we try to get higher capacities there as well. Uh, the other material that we are looking at, and it's especially gained a lot of interest in the automotive market in North America, is the HLM. It's the market mostly everyone calls it LMR, the layered manganese rich materials. Uh, we have a few OEMs in North America announcing their plans to commercialize cells with LMR technology. So this is also a low-cost technology addressed for the automotive market, and we are now at pilot scale for this material, and we can we are operating at 4.35 to 4.4 volts at this stage, can get a capacity of 205. But eventually we would like to push the upper cutoff voltage higher to get more benefit, higher capacities. It has to be, of course, coupled with electrolyte development. And then it's a strong feedback loop with customers is very important for this material because it's not as mature. But we have a continuous ongoing development for the last few years, which has we are able to get really significant advances in this technology. So, and then there are other technologies like LNMO and DRX, which are still early R&D and still a lot of time for bringing it into mass production. So, looking at the key lithium-ion battery markets in North America, so I've divided into two. The electric vehicles market, we have really discussed that. Uh, it's a bit doom and gloom is there, but I think the market will soon come back. It's not really declining. It's kind of stagnant or maybe gradually growing, not at the rate as we thought it would. But eventually, I think it will come back strongly as well. But we see a clear trend of low cost materials, low cost cells in this market. Scalability is also very important. A non-FEOC supply chain is preferred, not always really mandated, but generally preferred by OEMs to have as much as a non-FEOC compliant supply chain here. The other market we see is a smaller market than the EV market, but it's growing at a rapid pace. It's the non-EV. We have ESS, eVTOL, drones, defense markets, and then specialized vehicles for defense, for example. This a general trend that we see in this market. It's high energy, high power, and very strict NDAA compliance. And I will discuss shortly what NDAA is, but this is because of defense application, because of national security applications and other things. We want to have the entire supply chain. We should be a FEOC, non-foreign entities of concern. Has to be US or US friendly supply chain. So this is where I think the real opportunity right now is to develop a supply chain that can comply to these regulations. So now just to quickly give you an overview of what the NDAA is. So the National Defense Authorization Act, NDAA, is a US federal law which is passed every year. And it authorizes funding levels and policies for the Department of War, used to be DoD, now DOW, and for the national security programs. It sets strategic priorities for military defense and how defense funds can be used. However, over the year, it has become more broadly applicable. Uh, it is being applied to supply chain resilience, to industry protections, and restrictions on foreign companies and technologies. And we see the scope of NDAA growing as there's a lot of, I would say, tension growing between US and China and US and other FEOC countries. So what would be the implications of NDAA on EV battery supply chain? You can see here the Section 842 prohibits defense industry from acquiring batteries from for FEOC regions. And recently they've announced restrictions on new acquisition programs from Jan 2028. Standard uniformly applied battery platforms from Jan 1st, 2029, and then existing programs have been given a little more time. By Jan 2031, they have to move out of China supply chain as well. So materials for recycling, if the recycling can be done in US or friendly countries, then that's the origin point that's been considered. And it's still not completely clear as to what components are included in this supply chain requirement. But as we talk to more and more people, and as the legislators start getting more clarity on this, we expect it will really go deep into the supply chain right now. So we expect that the functional cell components, cathodes, anodes, separators, anode foils, and all other important constituents will be required to be NDAA compliant. So if you look at what is exempt, again, this language adds a little bit of confusion. But again, I think they are reviewing the next NDAA Act. I think for this year, and I think we will see more clarity. But I think 95% of the cost of the functional cell components, um, nine, the it should be sourced from other than FEOCs. So that's going to be a very important factor. So I don't think any company would risk at this point having an FEOC based supply chain, even if the final assembly is in in US or friendly countries. What is excluded right now is the consumer electronics, and then off-the-shelf items for equipments, and then R&D materials even for the Department of War. So right now that is excluded from NDAA. So now this is an image from Project Blue. It's interesting, showing the regional constraints and how China dominates production. When you look at mining, all the steps in the whole supply chain, mining, refining, precursor, cathode, and cells, you can see the China-owned supply. So nickel 42% here, yeah, in the mining, 59% in refining. For the LFP, LMFP, precursor and cathode production, almost complete monopoly of China, even in cell production, like very small percentage outside China. But for mining, we have about 14% in US or IRA compliant supply. So these are like US IRA compliant allies who were kind of included in the IRA with the free trade agreements. In the cobalt supply chain also, you can see China's dominance here. NMC cathode production is a bit less as compared to the US friendly supply chain, but if you see upstream, it's still a similar story. And then manganese, again, manganese, we're talking about LMR, but you see a lot of refining being dominated by manganese, by China. So there is still opportunity to really grow that, and we there are some secured supply chain, but it's important to understand that the option. It's important to know that we need to expand the supply chains beyond China if we really want to comply to these regulations. So to show you here, Umicore has been a player, as I had shown in an earlier slide. It's been a long time. We have geographically diversified our sources. We have a China-based supply chain. We also have a non-China, non-FEOC supply chain for North America and European markets. Here, this picture gives you an overview of Umicore locations and our supply chain. So raw materials, we are diversifying that. We deal with metal intermediate, recycling, metal salts, so different sources all over the world. So as diversified as possible outside China as well. For refining, for the China-based supply chain, we have Jiangmen, Guangzhou, but for a European supply or North American friendly supply chain, we have Kokkola in Finland and Olen in Belgium, where we can obtain refined materials. For the precursor, for China, we have Jiangmen, but we are making a lot of precursors in Finland, which is a European production for PCAM. And in South Korea also we make some PCAM. And the cathode production for North American supply chain, we have South Korea and NISA. Both are kind of it's non-China location. So we have a really strong supply chain. If customers prefer a non-China supply chain for a particular application, Umicore is in a position to provide that. Uh, yeah. So key points, I would say summary before we end. North American battery markets are growing rapidly across both EV and non-EV application, more so in non-EV right now. NMC materials are emerging as a key technology path, offering competitive performance and scalability. NMC is going to be important for non-EV application because LFP, maybe LFP for energy storage, but not so much for other applications. Regulatory pressure is increasing with the non-FEOC and NDAA compliance becoming critical success factors for companies. So, Umicore is uniquely positioned to lead with a North America friendly compliant supply chain. So we need to really start securing the supply chains in order to be compliant and have a secure non-China supply chain for these markets. And that's where I think Umicore can help. Yeah, so that's the overall message. So I'm happy to get some questions.